Hi again, I'm back with another video, and this one's about colloidal silver. I'll show you how I've done it in a minute, but this here on the left, you can see this has been sat around for 7 days, and you can see that, you know, it's still milky, it still looks good, it doesn't smell in the slightest, and yeah, well, it's been, like I said, it's been sat around for 7 days, and all I did was add some colloidal silver to this one. Now this one has been sat around exactly the same amount of time, and you can see I'm not going to smell it, because you know what bad milk smells like. And it's gone really nasty. It's putrefied, it's gone brown, it's got a horrible colour to it, and it's really absolutely, in fact I can smell it now actually, now I disturbed it. So yeah, right, so I'll get on and show you the little machine that I used to create this. That's real ghetto, it's totally cheap and inexpensive, so yeah, I'll show you how I've done it. Right, I know tons of people have made videos out there on colloidal silver, and it may look like I'm jumping on the bandwagon, but I think I've found something new. Well, it's new to me anyway, and I haven't seen anything else like it on YouTube. And that is using, well, first of all, I tell you that it was said that the best way to make colloidal silver is to use you know, 60+ volts AC, and I was wondering how I could get, you know, above this is only a 30 volt power supply, and I was wondering how on earth I'm gonna up the power, you know, try and get more power out of it. I really need small milliamps, but so I got the idea of, rather than using AC, what about pulsed DC? So I thought about that, and I thought, well, how am I going to do that then? And I remembered that I've got an old Bedini motor sat around. It's been sat around doing nothing really. It's just part of my last experiments, but there it is. It's just the old Bedini motor. You've seen it in other videos. It's old school, it's proper ghetto again, and yeah, it works. But the trouble is, when you switch it on with a 12 volt system, you get something like 160 or 120 volts. Let me just try that a minute. And give her a spin. It's on really low voltage, so I've got to give it a little push. And there you can see 5.3 volts and 8 millivolts. So there's she's rotating around, and the output at present, I'm charging a capacitor, and you can see that's going up, and that's 73. It's just charging a capacitor, that's all it's doing. So there, I've gone above, I found that around 80 volts to 86 volts was really good. It started producing the colloidal, you know, proper silver without the, well, with less tindall effect, if you know what that means. But if I turn the voltage up, let's see if I can get them close together. I turn the voltage up to around 12 volts. start getting, you know, the Bedini motor starts speeding up, and oh, okay, it's gone above 200. Ignore that decimal point. Something's gone wrong with that decimal point. But that is 220 volts. You can see clearly that it's on the high volts mark. 220 volts from 12 volts. So that's no good. That's completely no good. It's way too high, and that tindall, you know, it'll be really bad for that effect. So if I bring it down to 5.3 again. Should drop. Now I need to short to show that really. Oh, okay, it's gone down below 200 now, but that will go down, that will drop, the capacitor will, to 80 volts again. But yeah, so once I get around 80 volts, then I'll start, you know, I can use that. It seems to be useful, and like I say, it's a Bedini motor. You can easily find the instructions online on YouTube. They're all everywhere, how to build that machine. And I've got 1,000 turns on the coil, approximately 1,028 actually. But yeah, that's all I need to do to get that voltage, and it's not AC, it's post DC, and it seems to be really working really good. So there we are. It's dropping. It will drop down to 80, and that will be usable for me. Right, so I'll move on now and show you the lid, my little jar, and how I set that up. Right, is the lid I was talking about. It's just got a 12 volt motor on it, 2 pins of silver and a variable resistor, and if we look underneath we can see that I've got the silver wire at 2 different lengths. And now the longest one is the positive, it's the anode, and the shortest one is the negative. And you have to clean that negative up, you know, like every 10 minutes or so, because it gets gunked up with silver oxide, and it's not very good having that going into your it just increases the ppm beyond something that you know, those particles will fall to the floor. They're not really part of, they're not bound, they're not bound into the water. So, but my little stirrer there, it's just run off a 12 volt battery, which is connected to a solar panel, and that's it really. But the positive one is longer for obvious reasons, because we want positive ions. And again, the reason I actually use the high voltage is to avoid getting the ionic silver, which isn't a problem. You'll get some anyway, it's not an issue, but I do like to avoid it, because otherwise it won't really mix correctly. The particles are too big, and it doesn't allow the silver particles to become suspended. But when I first start, I have to add an electrolyte, which is bicarbonate of soda. This is the mix. I'll give you the instructions to all of the mixes and everything in the description, but that electrolyte is just a simple tiny amount. You only need 1 or 2 drops of that, literally, and that's good. And once it's finished, I use a reducing agent which is inverted sugar syrup. You can see it behind it, but this is watered down half and half, and that's your negatives. That's your negative ions that will connect to the positive ions and create the nano silver metal that you're after, and the liquid should turn yellow or a yellowish colour after it's finished. Yeah, that's my little machine. That's how I do it. I could show you an end product, maybe in another video, just to show you the end result, and maybe the difference between the tindall and the ionic. You know, you get to, saying that, you will still, if you get enough particles suspended in this water, you'll still get tindall effect. And you know, that's just larger particles, that's all. They're not actually nanoparticles. The more of the tindall effect that you have, the more silver particles that you can actually see, and you shouldn't be able to see a nanoparticle. It's just literally impossible to see a nanoparticle. But there you go, that's it. That's my little machine. And whether I'll post another video, I do not know, because there's loads of them that do demonstrate what happens, and this does every now and then. This is at room temperature as well. Sometimes it makes it goes yellow, and every now and then it doesn't. I'm still trying to work that out, but I think that's down to room temperature. If it gets too cold, it may not work properly, but you can always try heating it up to 140 degrees Fahrenheit in order to correct that. And sometimes there's once that I found that it didn't actually correct it. You know, experiment, find out for yourself. But this is an awesome way to create a real colloid with real nanoparticles, with less of the tindall effect. I mean, I will find the proper voltage if there is one, and probably get back to you when I've perfected it, or if I perfect it, if I can even be bothered, because I've found that both ionic silver, the larger particle tindall effect silver, and the colloidal silver all do the same to the milk. They all keep it sterilised from nasty bacteria that can be quite harmful. So yeah, there you go. I hope you find that interesting, using a Bedini motor to actually produce a colloidal silver. It's quite useful. It's low voltage, it's low energy, 7 milliamps is awesome. And you just run that for 1 or 2 hours, depending on how strong you want it, how much ppm you want it, and then you know, you can just drink it once it's made. So yeah, I hope you found that useful. Thanks for watching.